Hello everyone, I am Lucas Vege, a PhD student at UFMG in Brazil. In this work, my advisor Marco Túlio Valente and I investigated code smells in the Elixir language through a great literature review. Elixir is a modern functional language that has high performance in parallel and distributed environment. It was designed from a mix of inspirations. Its syntax is friendly and highly productive, being based on Ruby. It uses immutable data like Haskell, making it easy to use in concurrent environments. Elixir runs on Beam. It is Erlang's virtual machine known for its robustness. In addition, it is an extensible language as it incorporates metaprogramming concepts from Clojure. Overall, the popularity of functional languages is on the rise in the industry. More than 600 companies around the world already use Elixir in production code, some of which are well known. As with any other language, it is expected that Elixir developers can make bad design decisions by implementing suboptimal structures known as code smells. Although the popularity of functional languages is on the rise, few studies focus on the quality of systems implemented in such languages and known specifically on Elixir. To understand the problem, we proposed 3 research questions. First, we searched for discussions by Elixir developers on the 22 traditional code smells cataloged by Fowler and Beck. Next, we investigated if the discussions extend to other language-specific smells. Finally, we checked the code smell detection capability of a popular static code analysis tool in Elixir. To investigate the first 2 RQs, we reviewed the gray literature since there are no works in this context published in the scientific literature. So, we structured and calibrated a search query with the terms Elixir, code smells, and their synonyms. This query was later run on Google to find discussions about the suboptimal structures. As around 700,000 documents were returned, we limited the reading to the top 60 listed by Google, and from those, we filtered out 17 documents that were related to our RQs. From these 17 documents, I extracted sentences that characterize discussions about code smells. It was later validated by the second author of this work. Credo is the main static code analysis tool for Elixir. For this reason, we decided to deeply analyze its documentation for warnings related to detecting code smells. For the first RQ, we found discussions about 11 out of 22 traditional code smells, with comments being the most discussed smell among Elixir developers. This code illustrates the kind of sentences extracted from the gray literature. In it, the author discussed long parameter lists. According to him, although Elixir does not have class support as an object-oriented language, developers can easily refactor this smell due to the extensibility of the language. In the second RQ, we found 18 code smells specific to Elixir and not yet cataloged in the scientific literature. We categorize them into 2 groups. The first one involves 10 smells related to design issues and therefore affecting larger chunks of code. These smells can harm code readability and maintainability, for example. The second is composed of 8 smells related to low-level concerns that affect short snippets of code. These smells can harm systems performance. Our GitHub repository has more details on these specific smells. Finally, in the last RQ, we identified that Credo is able to detect only 3 out of 40 possible smells investigated by us. Of these, 2 are traditional smells and 1 is Elixir specific. No design-related specific smell is currently detectable by Credo. In light of these results, we plan to expand and validate our catalog of smells for Elixir by mining code repository and conducting surveys and interviews with Elixir developers. Subsequently, we intend to extend Credo, enabling to detect a greater number of smells in relation to the version analyzed in this work. Finally, we intend to investigate code smells in other modern functional languages, such as Clojure. Thank you all for your attention.